Shall we start the program? Pradeep sir,
Yes, ma'am.
shall we start the program, sir?
Yes, ma'am. Start the program, ma'am.
Okay, sir. Good afternoon to everyone present here. We now behind session 1 of International Conference on Emerging Technologies and Future Innovation 2025, featuring technical paper presentation from esteemed researcher and academician and students across India. The session will be chaired by Dr. I. Karol sir, Assistant Professor, Department of Information Technology, St. Joseph College, Tiruchi, and co-chaired by T.K. Pradeep Kumar sir, Assistant Professor, Department of Computer Science and Engineering, AMC Engineering College, Bangalore. I request both respected session chair to kindly take charge of the session. We now behind the presentation. Now I would invite Rama Subbalakshmi ma'am. Rama Subbalakshmi ma'am.
Good
Ram,
afternoon.
good afternoon ma'am.
Um,
Can you start your presentation ma'am?
starting.
Ma'am, are you available?
Is our screen visible? Cancel பண்ணிட்டு Did our did you see our screen, ma'am?
Yes ma'am.
Okay.
Good afternoon, everyone. My project. My paper title is Heart Disease Risk Prediction on Machine Learning Model. The motivation of the project is heart disease is one of the major causes of death worldwide. Early detection is difficult due to hidden and overlapping symptoms. Manual diagnosis is time consuming and depends on expert judgment. There is a need of an automated and accurate fast system for risk prediction. Machine learning helps to identify hidden patterns from the patient data. Predictive system assist doctors and patients in taking early prevention actions. This project aims to ML model to predict heart disease risk on support and health decisions. The objective of my paper is to collect and pre-process the patient health data like parameters in the dataset to implement multiple machine learning like logistic regression, decision tree, random forest, and KNN using in Python to evaluate and compare the model using a matrices like accuracy, precision, recall, FN score, and ROC curve to identify the most effective model for I will continue my session. The problem statement of the paper is Hollywood disease remains the leading cause of death worldwide. The effectiveness treatment largely depends on the early detection of individual at risk. However, the traditional diagnostics approaches are often time consuming, require expert interpretation, and may not always provide a consistent accuracy. The problem is to design and implement Python-based machine learning system that accurately classify heart disease risk levels. The challenges lies in selecting appropriate algorithm, handling diverse features, improving prediction accuracy, and developing a reliable model that can assist healthcare professionals in making a time decisions. This is the abstract of my paper. The introduction. I applied algorithm like logistic regression, decision tree, random forest, and support vector machine, and then compare them using a accuracy, precision, recall, and FN score. The idea is to create a reliable predictive model that can support the doctor making quicker and more accurate decisions. Literature review. Methodology of the paper is data collection, pre-processing, train and split, model training, probability-based risk classification, model evaluation, and then Flask web application. Software requirement, architecture design, user doctor or patient can enter the parameters. The process begins with the either healthcare provider or patient initiating the interaction with the system. User interface, user input patient informations like age, gender, blood pressure, cholesterol, etc. to the user-friendly form. Data pre-processing, the system cleans the input data, handling the missing values or errors. ML model, using the 5 models to evaluate, train the model, and evaluation. Best model selection, choose the best model with the high performance. Prediction output, high risk, medium risk, and low risk. Classify the risk. Database design. These are the database design and description. They are the 5 models and their advantage and disadvantage and users in this project. Model prediction and evaluation. Model training output. This is the training output of the paper. This is the web page interface of the result. After the values and parameters are entered, they predict the low risk, and between the 5 models are compared: logistic regression, decision tree, random forest, KNN. The all models are trained and predict their result, and the probability result also show in this picture. The first one is low risk, and the next one is medium risk and high risk. These are the result of the papers. This is predicted by the 5 models and probability values. These are the comparison shot between the 5 models and the feature importance, confusion matrix and accuracy result for the 5 models. Then conclusion. The conclusion of my paper is machine learning techniques after powerful tools for predicting heart disease risk using a clinical and demographic data, comparative evaluation of algorithm including random forest, supported vector machine, decision tree and logistic regression. KNN reveals that ensemble method provide superior predictive accuracy, effective pre-processing steps such as feature encoding, normalizing play a crucial role in optimizing model performance. This result highlighting the potential of predictive model to support healthcare professionals in early detection risk assessment of the heart disease. This paper is conclude that early detection of the heart disease based on the health parameters of the patients.
Well done, Ramasubbu, Lakshmi. I want to clarify a few doubts regarding it. So, which model gives better accuracy out of 5 proposed models? You are choosing 5 proposed model, right?
KNN give the best model.
Okay.
This is the KNN training result of the paper.
Okay. What is the how do you collect the demographic data using your proposed?
Data set is collected from UCI heart disease data set.
Okay, thank you. If you have any doubts, you can clarify your doubts, ma'am.
Good afternoon, ma'am. I am Pradeep Kumar, Assistant Professor AMC Engineering College.
Yes, sir.
What is the authenticity of the data, ma'am? What is the evidence that the data is correct or okay?
So it is a benchmark data. You have to collect. You have to store the data in that is Kaggle data set.
So it's not collected from any hospitals.
No, it is stored in a cloud. So you have to collect it. You have to collect it from Cleveland Clinical Foundation.
That's what authenticity. What is the evidence that this data is having authenticity? What is the evidence that this data
Machine
is right?
learning repository, you have to collect it. Authenticity is UCA machine learning repository.
No, ma'am. The question is the data, whatever you are collected or using from Kaggle, is it the right data authenticated by any organization?
Yes, it's from hospitals we can collect it, sir.
From what hospital? What is it hospital? What is the source? Is it for Indian? Applicable
Available
for
in
Indian?
Barney hospitals. It's in Tirunelveli.
So it is secondary data then.
Yeah.
Ma'am, this scores you are shown, right? Will you explain that scores and what basis that has been calculated?
Which score, sir?
That F1 score, that accuracy, whatever it is.
So based on the training model, you have to apply the formula for it and get that accuracy, precision, recall, F1 score.
Yeah, what is that data you used for predicting that accuracy? Which column you used for this?
So from the training data set, you have to collect it, sir.
That's what from the data set.
Based on that model, you are choosing which model you want to choose it. So whether it is to be gain and mean,
In this column, we are saying age, sex, chest pain.
value, how to choose
Yeah.
it, and you have to
In
predict
this,
the value.
which column you used for calculating that accuracy?
What, sir?
In this, which column data majorly you used for calculating that accuracy?
So you know that the confusion matrix, you already have that predicted samples, and with respect to training samples, you have to compare those samples, and you have to the difference between this input as well as predicted one. You have to get the variance of it, and you have to predict it.
Okay, ma'am. Thank you.
Okay, thank you, sir. Next, cloud security using deep learning ANN approach. Miss Susma ma'am, are you available? Susma ma'am. Susma ma'am.
Hello. Good afternoon, all. This is Sushma here.
Yes, ma'am.
Yeah.
Ma'am. Okay, next part is presentation. Development of a smart recipe generator using Open AI GPT-4 and real-time streaming. Or Karthikeyan sir. Karthikeyan sir.
Present, ma'am. Good afternoon, everyone.
Good afternoon, sir.
Audio is clear, ma'am?
Yes, sir.
Ma'am, I think I've connected. I'm trying to share my screen.
Ma'am, kindly please wait, ma'am. Another presentation is ongoing, ma'am.
Okay.
Okay, ma'am. Karthik sir, you can start.
Oh, okay. Screen is visible, ma'am. Good afternoon, everyone. Screen is visible, ma'am. Or ma'am?
Yeah, sir, visible, sir.
Okay. This paper presentation topic in the development of smart work generator using OpenAI and real-time streaming. My guidance is Assistant Professor of Department of Computer Science, School of Information Technology, name K. Sutravadi sir. My name is Karthikeyan R. Students and another person is P. Prakash Ambros.
For conferences, we value conferences don't have much.
Abstract. Personalized cooking assistant. Solution வந்து AI powered web application for automated recipe. Core tech stack வந்து front end வந்து React JS, back end வந்து Node.js with Express. AI மாடல் வந்து இதுல என்ன AI மாடல் யூஸ் பண்ணிருக்கோம்னா OpenAI GPT-4 வந்து. இதுல ஸ்பெஷல் ஃபியூச்சர் என்னன்னா நீங்க ரியல் டைம்ல ஸ்ட்ரீமிங் பண்ற வந்து அதாவது ரியல் டைமா சர்வர்ல இருந்து எடுக்கும். நீங்க கொடுக்குற ரெசிபி வந்து நீங்க ரெசிபி கொடுப்பீங்களா, எனக்கு வந்து இந்த ரெசிபி இருக்கு, எனக்கு இந்த மாதிரி ஒரு ஃபுட்டு வேணும் அப்படின்றத ரியல் டைமா எடுத்து கொடுக்கறது தான் என்னோட இந்த பேப்பர் ஒர்க்கோடது. இந்த பேப்பர் ஒர்க்ல ஃபர்ஸ்ட் இன்ட்ரடக்ஷன் என்னன்னு பார்த்துக்கிட்டிங்கன்னா, ஃபர்ஸ்ட் நாங்கள் 2 விதமான இது ஒர்க் பண்ணியிருக்கோம், ஜென்ரேட் பண்ணியிருக்கோம். இன்கிரீடியன்ட் வந்து எப்படி 2 விதமாக ஜென்ரேட் ஆகும். ஒன்று வந்து இன்கிரீடியன்ட் பை ஜென்ரேட் பை நம்ம கொடுக்குற இன்கிரீடியன்ட் வச்சு ஜென்ரேட் ஆகும். இன்னொன்று வந்து ரெசிபி நேம், நம்ம கொடுக்குற ரெசிபி நேம் வச்சு ஜென்ரேட் ஆகும். இந்த ஜென்ரேட் பை இன்கிரீடியன்ஸ்ன்றது என்னன்னா, இப்போ நம்மகிட்ட இருக்கிற வந்து என்கிட்ட வந்து இந்த வந்து ஐட்டம்ஸ்லாம் இருக்கு. என்கிட்ட வந்து உதாரணத்துக்கு சிக்கன் இருக்கு, ஆயில் இருக்கு, அதுக்கு 2 மசாலா ஐட்டம் இருக்குன்னா இதை வச்சு என்னால் என்ன ஜென்ரேட் பண்ணணும், என்னால் குக் பண்ண முடியும்னு பார்த்தீங்கன்னா அந்த மாதிரி ஜென்ரேட் கொடுக்கும். இன்னொன்று வந்து ஸ்ட்ரைட்டாக வந்து என்னோட ரெசிபி நேமே நான் கொடுத்துட்டேன்னா, இப்போ எனக்கு வந்து சிக்கன் பிரியாணி வேணும் அப்படின்னு நான் ஸ்ட்ரைட்டாகவே கொடுத்துட்டேன்னா அதுக்கு என்னென்ன நீங்கள் ரெசிபி வேணும், என்னென்ன ஐட்டம் வேணும்ன்றதை எல்லாத்தையும் வந்து சொல்லிடும். இதில் இதுதான் உங்களோட வந்து இன்ட்ரடக்ஷன் அப்ஸ்ட்ராக்ட். அதில் வந்து இன்ட்ரடக்ஷன் சொல்லிட்டேன். இன்ட்ரடக்ஷன் வந்துட்டு ரியல் டைம் ஜென்ரேஷனு அதில் 2 டைப்பில் நாங்கள் கொடுத்துருக்கோம். ஒன்று வந்து ரெசிபி ஜென்ரேட்டட், இன்னொன்று வந்து ரெசிபி நேம் ஜென்ரேட்டட் வந்துச்சு. இதில் வந்து ஸ்டெடி அண்ட் ஓவர் ஆஃப் ஜென்ரேட்டிங் இதில் வந்து முன்னாடி நான் சொன்ன மாதிரி தான். இதில் நாங்கள் வந்து என்ன பிளாட்ஃபார்ம் யூஸ் பண்ணியிருக்கோம். ஃப்ரண்ட் எண்டில் வந்துட்டு ஃப்ரண்ட் எண்ட் வந்து ரியாக்ட் ஜேஎஸும், பேக் எண்ட் வந்து நோட் ஜேஎஸும். இதில் நாங்கள் யூஸ் பண்ணிருக்கிற மாடல் வந்து இது GTPன்ற ஒரு 4 ஓப்பன் 4 மாடலில் பண்ணியிருப்போம். இப்போ வந்து முன்னாடி ஏற்கனவே இவங்க இதில் என்னது ப்ரொபோஸ்ட் ஒர்க் அண்ட் எக்ஸிட்டிங் ஒர்க்கை வந்து பார்ப்பாங்க. இப்போ நாங்கள் என்ன புதுசாக ஆட் பண்ணியிருக்கோம்னா, இப்போ எக்ஸிட்டிங் ஒர்க்கில் என்ன பண்ணியிருக்காங்கன்னா, அவங்க வந்து செட்டைன் ஒரு டேட்டா செட் இருக்கும். அந்த டேட்டா செட்டில் இருக்கிறத மட்டும்தான் நம்மளால வந்து எடுக்க முடியும், கிளைம் அந்த இது வந்து ஜென்ரேட் பண்ண முடியும். இப்போ உதாரணத்துக்கு நீங்கள் ஒரு 10 ஃபுட் ரெசிபி நேம் தான் இருக்குன்னா, நீங்கள் அந்த 10 தான் வச்சு பண்ணாமல் தான் உங்களால் அதை வந்து எடுக்க முடியும். இப்போ நாங்கள் இதில் புதுசாக என்ன ஆட் பண்ணியிருக்கோம்னா, இந்த ரியல் டைம் இன்ஜின் சொன்ன அந்த டாப்பிக்கில் இருக்கிற மாதிரியே ஏஐ வந்து இதோட சர்வர் சைடோட லிங்க் ஆகிருக்கிறனால நான் வந்து இப்போ நான் என்ன இது கொடுக்குறேனோ அதுக்குரிய இதை கரண்ட்ல இருக்கிற ரெசிபி வந்து அதை ஜென்ரேட் பண்ணி அதுவே கொடுத்துரும். இதுதான் எங்களோட ப்ரொபோசல் ஒர்க்கு. அதில் வந்து சிஸ்டம் ஆர்கிடெக்சர்னு சிஸ்டம் ஆர்கிடெக்சரில் வந்து பார்த்தீங்கன்னா இந்த இடத்துல இந்த கிராஃப் மொத்தம் யூசர்கிட்ட இருந்து ஃபர்ஸ்ட் 2 விதமான இன்புட் நான் போகணும்னு சொல்லியிருந்தேன். ஒன்று வந்து ரெசிபி நேமு, இருக்கிற ரெசிபி வச்சு எப்படி ஜென்ரேட் பண்ணுறதுன்னு. அதில் பார்த்தீங்கன்னா யூசர்கிட்ட இருந்து என்டர் யூசர் இன்புட் தான் இன்கிரியன்ட் அல்லது ரெசிபி நேம். இதை வச்சு நம்ம இது பண்ணுவோம். ஃபர்ஸ்ட் வந்து யூசர்கிட்ட இருந்து டேட்டா போகும். நம்ம என்ன விதமான டேட்டா கொடுக்குறோமோ அது வந்து ரெசிபி ஜென்ரேட்டட் சிஸ்டம்கிட்ட போகும். இது வந்து ஒன் டைப் ஆஃப் இன்ஜின். இந்த இன்ஜின் வந்து நம்ம கீழே வந்து பார்ப்போம். அதுக்கடுத்து இந்த இன்ஜின்லேருந்து ஃபர்ஸ்ட் என்ன பண்ணோம்னா OpenAIக்கு போகும். OpenAIல போயிட்டு இது வந்து நம்ம கொடுக்குற டேட்டாக்ல இருந்து அந்த டேட்டா வந்து ஸ்ட்ரீம் பண்ணி கொடுக்கும். எந்த மாதிரினா அதுக்குரிய இமேஜ் கொடுக்கும், அதில் என்ன கலோரி இருக்கு, எத்தனை % வெயிட் இருக்கு, எல்லாத்தையும் வந்து சொல்லும். இதில் 2 விதமா ஒன்று வரும். நான் சொல்லியிருந்தேன்ல, ஒன்று ரெசிபி ஜென்ரேட்னா டெக்ஸ்ட் ஃபார்மேட்ல ஒன்று வரும், இன்னொன்று வந்து இமேஜ் ஃபார்மேட்ல ஒன்று வரும். இந்த இமேஜோட இந்த ரெசிபி பண்ணீங்கன்னா இந்த ஃபுட்டோட இமேஜ் வந்து இப்படி தான் இருக்கும் அப்படின்றது மாதிரி சொல்லியிருப்பாங்க. அதில் தான் வந்து அதுதான் நான் வந்து இந்த ஃபிகர் 3.1 வந்து சொல்லியிருக்கேன். நான் ஒன்று சொல்லியிருந்தேன்ல, இந்த ரெசிபி ஜென்ரேட்டர் சிஸ்டம்னு, இந்த சிஸ்டமே இங்கே வந்து எலாபரேட் ஆகிருக்கும். இங்கே இந்த இடத்துல வந்திருக்கும். இதில் ஃபர்ஸ்ட் பார்த்தீங்கன்னா அதே ஒர்க்கு தான். ஆனால் இங்கே வந்து செப்பரேட்டாக பிரிஞ்சிருக்கும். என்னென்ன பிரிஞ்சிருக்குன்னா, இந்த ரெசிபி ஜென்ரேட்ல நான் சொன்ன மாதிரி ஒரு ஃபார்மேட் ப்ராம்ப்ட் வச்சு நம்ம பண்ணியிருப்போம். என்கிட்ட இந்த இதுதான் இருக்கு, இந்த ரெசிபி தான் இருக்குன்றத ப்ராம்ப்ட் வச்சு அது OpenAIட்ட போயிட்டு அந்த OpenAIனா ஜென்ரேட் அந்த டெக்ஸ்ட் நமக்கு என்ன வேணுமோ அதை கொடுத்துரும். இன்னொன்று வந்து இமேஜ் மூலியமா அந்த இமேஜுக்கு எப்படி சர்ச் பண்ணி எடுக்கணும்னா அதுக்கு நம்ம கொடுக்குற அந்த அந்த இது என்னது இமேஜ் வந்து சர்ச் இன்ஜின்ல வந்துட்டு போயிட்டு இதுக்கு ஒரு ஏபிஐ இருக்கு. இங்கே ஓப்பன் ஏபிஐன்னு யூஸ் பண்ணியிருக்கோம்ல, இமேஜுக்கு வந்து இமேஜ் ஏபிஐன்னு ஒன்று யூஸ் பண்ணி அந்த இமேஜ் வச்சு அதுல இருந்து டேட்டா வந்து இதில் வந்து ப்ராசஸ் ஆகும். ப்ராசஸ் ஆகிட்டு நமக்கு என்ன வேணுமோ அதுதான் வந்து திரும்பி இங்கே வந்து ரெசிபி ஜென்ரேட்டட் இன்ஜினில் வந்து ஸ்டோர் ஆகிடும். இந்த ரெசிபி ஜென்ரேட்டட் இன்ஜின்ல இருந்து தான் நமக்கு வந்து திரும்பி யூசர்கிட்ட இருந்து ரிட்டர்ன் வந்து ரெஸ்பான்ஸாக போகும். அது வந்து ரெசிபியாகவும் போகும் அல்லது இமேஜாகவும் போகும். நான் ப்ரப்போஸ்ட் வந்து அப்ட்ராக்ட்லேயே சொல்லியிருந்தேன். நாங்கள் வந்து என்னென்ன யூசர் இன்டர்ஃபேஸ் யூஸ் பண்ணியிருக்கோம்னு அதை தான் இங்கே வந்து சொல்லியிருப்பாங்க. ஃப்ரண்ட் ஹேண்டில் வந்து ரியாக்ட் ஏபிஐயாகவும் பேக் ஹேண்டில் வந்து நோட் எக்ஸ்பிரஸ்னாலும் இந்த கரண்ட் ஏபிஐன்றது வந்து அந்த இமேஜ் ப்ராசஸிங் எப்படி நடக்கும்னா அன்கிளாஸ்ன்ற ஒரு ஏபிஐ மூலியமாக தான் நடக்கும். அன்கிளாஸ் ஏபிஐ தான் இந்த வந்து இங்கே வந்திருக்கும். அந்த இமேஜ் ஏபிஐன்றது தான் அன்கிளாஸ் ஏபிஐன்ற ஒரு மாடல். அது மேலே சொல்ல பாயிண்ட் மேலே இந்த அந்த 2 டயக்ராம் இருந்துச்சு பார்த்தீங்களா, அந்த 2 டயக்ராம் வச்சு தான் இங்கே கீழே இருக்கிற ரெண்டுமே அந்த 3.3Aவும் 3Bயும் வரும். அதுக்கடுத்து ரியல் டைம் டேட்டா ஸ்ட்ரீமிங்கை வச்சு நாங்கள் வந்து இப்போ நம்ம என்ன பண்ணியிருக்கோம் அப்படின்றது தான் நாங்கள் கீழே வந்து இமேஜாக கொடுக்குறேங்க. இதில் பார்த்தீங்கன்னா ஃபர்ஸ்ட் வந்து எங்களோட விண்டோஸ் வந்து இப்படி தான் இருக்கும், இந்த மாதிரி தான் இருக்கும். இதில் இந்த விண்டோஸில் ரெசிபி ஜென்ரேட்டர்னு ஒன்று இருக்கும். இதில் வந்து நம்ம என்ன வந்து இன்க்ரீடியன்ஸ் இருக்குது அது கொடுக்கணும். அதுக்கடுத்து ரெண்டாவது வந்து மீல் டைப், என்ன மாதிரியான மீல் டைப்ஸு, அதுக்கடுத்து வேற அந்த குக்கிங் டைமு, காம்ப்ளெக்சிட்டி, வேற என்னென்னலாம் வேணும் எக்ஸ்ட்ராவாக வேணுன்றதெல்லாம் இதில் கொடுத்துருவோம். கொடுத்துட்டிங்கன்னா அடுத்தது போயிடும். இதை நான் இந்த ஜென்ரேட் ரெசிபின்னு போட்டு இதுதான் எங்களோட மெயின் விண்டோ. இந்த மெயின் விண்டோவில் வந்துட்டு அதுக்கடுத்து நீங்கள் உள்ளே போயிடுவீங்க. ஃபர்ஸ்ட் பார்க்க போகிறது வந்துன்னா ஜென்ரேட்டட் பை இன்கிரீடியன்ஸ் பார்த்தீங்கன்னா இப்படி தான் இருக்கும். எங்களோட வெப்பேஜோட வந்து லோகோ ஃப்ரண்ட் பேஜ் வந்து இப்படி இருக்கும். இதில் வந்து இந்த மாதிரி இருக்கும் ஜென்ரேட் பை இன்கிரீடியன்ட். அந்த ஜென்ரேட் பை இன்கிரீடியன்ட் கொடுத்தீங்கன்னா இந்த மாதிரி ஒரு விண்டோ ஷோ ஆகும். இந்த விண்டோ ஷோ ஆகல நம்ம வந்து என்ன டீட்டெயில்ஸ் வேணுமோ அந்த டீட்டெயிலாம் கொடுத்துருவோம். டீட்டெயில் கொடுத்து நம்ம ஜென்ரேட் கொடுத்துட்டோம்னா நமக்குரிய அந்த இமேஜ்லாம் வந்துடும். இந்த ஜென்ரேட் ரெசிபி பை நேம் கொடுத்துட்டோம்னா நேம் கொடுத்துல அந்த இமேஜ் வந்துடும். அது மட்டும் இல்லாமல் அந்த இது கிராஃப் மாதிரி போட்டு இதுக்கு வந்து எத்தனை கலோரி இருக்குது, இதுக்கு வந்து எவ்வளோ மினிட்ஸ் செய்ய டைம் எடுக்கும் அதுன்றதையும் சொல்லிடும். அதுக்கடுத்து எவாலுவேஷன் ஆஃப் ரெசிபி, எவாலுவேட்டிங் த லெவல் ஆஃப் ரெசிபின்றது இந்த நீங்கள் ஒரு இது இருக்கும், நம்ம சமைக்கணும் ஒரு ஃபுட்ஸ் மேக் பண்ணுறோம்னா அதுக்குன்னு ஒரு ஆர்டர் வைஸாக தான் நம்மளால் வந்து அந்த ரெசிபியை போடணும். முன்னாடியே நம்ம கொஞ்சம் ஒரு மசாலாவோ ஒரு ஐட்டமோ முன்னாடியே போட்டோம்னா அது நல்லா இருக்காது. ஒரு டைம் சர்டன் பீரியட் ஆஃப் டைமில் தான் நம்ம அதை போட்டால் தான் அந்த ரெசிபி வந்து நல்லா இருக்குன்றதான் இங்கே வந்து இந்த இதில் சொல்லியிருக்கோம். எவாலுவேட்டிங் த லெவல் ஆஃப் ரெசிபின்றது எந்த லெவலில் இருக்கணும். இதில் வந்து லாஸ்ட்டாக நாங்கள் இதில் என்ன சொல்ல வரோம்னா முன்னாடி ஏற்கனவே இந்த மாதிரி நிறைய இருந்தாலும் அதில் ஏற்கனவே இருக்கிறத மட்டும்தான் ஜென்ரேட் பண்ணும். அவங்க கொடுத்துருக்க ஏற்கனவே சர்டன் டேட்டா இருந்துச்சுன்னா அதுல இருந்து மட்டும்தான் இது எடுத்து கொடுக்கும். ஆனால் இது எப்படின்னா நம்மகிட்ட என்ன இருக்கோ அதை வச்சு என்ன மேக் பண்ண முடியுமோ அதுதான் இதில் கொடுக்கும். தேங்க்யூ. இருக்கா?
Nice presentation, sir. I would like to clarify few doubts regarding your smart recipe generator. So your backend supports Node.js, yes, sir?
Yes,
and front end some other platform you have to choose it. So interconnect. How do you interconnect the backend tool with the front end tool? Is there any criteria for it?
மேம் ஜேஎஸ் யூஸ் பண்ணி தான் மேம் கனெக்ட் பண்ணிடணும். ஜேஎஸ் யூஸ் பண்ணி அது வந்து ஒரு பிளக்கின் மாதிரி மேம். நம்ம யூஸ் பண்ணுறது வந்து ஏன்றனால இது வந்து செட்டன் ஒரு பிளக்கின் மாதிரி இருக்கும். நம்ம அதை மட்டும் இங்கே வந்து ஸ்ட்ரைட்டாக பிளக்கிங் பண்ணிட்டோம்னா அது வந்து இதான்.
Is there any code for interconnect for backend and front end, sir?
மேம் நோ கோட் மேம். ஒன்லி டாக்குமெண்ட் தான் மேம் இப்போதைக்கு இருக்கு.
Without code, how can you interact with this recipe is ordered by that person?
மேம் இப்போதைக்கு எனக்கு இந்த சிஸ்டம் வந்து இப்போ வந்து நான் யூனிவர்சிட்டியில் இருக்கிற சிஸ்டத்தை வச்சு யூஸ் பண்ணிக்கிட்டு இருந்தேன். என்னோட கோடிங்லாம் வந்து என்னோட ஒரிஜினல் சிஸ்டம்.
Okay, sir. Can you give some examples of DALI models you specified in your paper? DALI models. What is the model reflected, sir? Sir, any idea?
No, ma'am, no idea. No idea. Sir.
Okay, sir. Thank you, sir.
Thank you. Thank you.
Pradeep sir, any question?
Ma'am, actually, I was not happy with the way they presented. They are reading from the paper. I was waiting for the presentation to be used for presenting. That is first observation I made.
Okay, sir.
And the second thing is, it is an international forum, I believe. It's talking in Tamil, and many things is not able to present wisely. So I felt like he is in beginning phase. So asking questions won't be. I felt he will not. He won't be in a position to realize. And very importantly, abstract is the extraction of the work. While explaining abstract, also I am not convinced. So I recommend the person to go through the paper deeply and use a presentation to explain. And when you're talking about front end, back end, nicely one of the panel member has asked that question, what is that code he used? And it was been told directly that I don't have any code. Means it's in a initial phase. So my suggestion is let him prepare well and present wisely in next upcoming events. Thank you.
Okay, sir. Next presentation, cloud security. Susma ma'am.
Yeah, yes, ma'am. I'm present, ma'am. I'm setting up the window.
Okay, ma'am.
Yeah. I should go to my window. Okay. Yeah, good afternoon to all. Is a
Sushma ma'am.
So cloud security using deep learning approach is what I'm going to present today. So this is all, as we know, we all in these times are dealing with the data which we are sharing in the cloud. So cloud is something that, I can tell it as which is public and which is accessible for everyone. And every time when we talk about cloud security, security is always a concern when it comes to the cloud data. So that is what made us to go into this topic, that is cloud security using deep learning, using ANN approach we are used. And so introduction, here we are using cloud storage. So cloud storage, I told you the introduction tells that only we are using lot of data in the cloud only we are using, okay, all sorts of sensitive data, everything from the cloud is come, whether it is a drive, everything we are making use of the cloud itself. So unauthorized acts, unauthorized extraction or unauthorized persons or threats is always there when we talk about the cloud. And traditional system, as the era goes on, 4G, 5G, 6G, we also see a lot of things are getting hacked, a lot of problems are there with the data. So traditional system doesn't work, we should be upgrading. Now we all know that we are in the level of AI scaling. So here even AI is also there, AI is in the market now. So based on that only, so we are making use of artificial neural networks and for the anomaly detection here. So our proposed system is based on the artificial, that is neural network concept we are making use for the anomaly detection. AN continuously learns and adapts the new attack pattern. So in this, what we are doing is we have set the pattern in the AL neural networks. There is already the patterns which is present. So based on that, whatever is there, if the new attack comes, okay, there is a patterns for that and which is getting detected. Is for everyone my voice audible? Yes?
Yes, ma'am.
Yes,
Good to
ma'am.
go.
Yeah, thank you, sir. Okay. So after problem definition, first we go to objective. What exactly we have done here is very, very important to detect and prevent unauthorized data exfiltration in the cloud system. Something which, some unauthorized, suppose we already provide the login access, everything is being provided, but still the unauthorized person will, when he try to do or when he try to, try to go into without accessing the data only, if he is trying to access that data, that is our first step, we are trying to stop it there only, we are not letting any.
Voice is not coming. Huh?
Sushma ma'am. Sushma ma'am.
So, as we are talking about, I'll try to explain the. Sorry for the inconvenience which is happening from mine to all the dignitaries who's present there. I know my internet connection is quite problematic today. I'm really sorry for what is happening. So yeah, and then my hidden layer will contain, as I told you, we are working with the ANN neutral pattern. So all that will be present in the same layer. Then the output layer, which is inside the system, that is sigmoid function for the binary classification based on the normal user behavior and the suspicion user behavior. Next we have how we have implemented, that is data split with training and testing. We have done 80% of training, and testing we have to do with the 20%. Then binary cost entropy with for the loss function, and ADAM optimizer ensures faster convenience. Dropout layers prevent
Susma ma'am.
in paper. So last one is discussion that is we had between our group members, where ANN model adaptation dynamically to evolving the threats. So what and all the threats we saw and how we deal with, so that when we are trying to get into this, we also came to know what is the behavioral based detection. After, as I told you, the main difference which we saw was if the person who is present, like the normal person, he is trying to just extract the data and to work more on the data and to, but if you are talking about anomalous or this one, he is only interested in the data which can be extracted, the confidential data which is trying. That is the main threat which we saw. Then again, real time detection and alert system enhances the cloud. Yeah, we had alert system in the, as I told you, as soon as we know it's some unanimous or some threat which is coming up, we had a signal that someone is trying to enter. We had a beep. We had a telling whoever is working on that system. We had the beep. Then scalable to enterprise level data volume. So we are trying to put it into large volume of data sets. Then what we are seeing in future is to put it into LSTM and RNN model. So my conclusion, what exactly we have done is, from this my paper, what we have extracted is all four on working ANN based deep learning approach for real time detection, what I explained till now, what and all the data extraction or data extrafiltration which we are doing. Then behavioral analysis, as I told you, if some threat is coming, what's his behavior and what is the other user behavior using IP addresses as such. Then future, what are we going to do is ANN model with hybrid security framework. We will still be try to adapt in this system, promising direction for reboost and cloud security. So this was all about my paper.
Okay, ma'am.
Sir, anything about the questions? Any questions?
So how do you make the security using LSTM or RNN models for temporal analysis? How do you analyze the data? Cloud secure data is to be a robust one.
Yes, ma'am.
Can you explain?
No, ma'am. Come again. I couldn't get your question.
So you are choosing for temporal analysis, you have to choose two models, right?
Yes, ma'am.
LSTM as well as RNN, right?
Yes, ma'am.
So
LSTM and RN.
okay. Out of these two models, you have to make the securities robust, right?
Correct. You have to
So,
make the second.
yeah, okay. Then how do you make it as a cloud security with based on the robustness? How do you keep it using temporal analysis? Did you get the question? Hello?
Any other questions?
Is it generalized for all the cloud service providers, or is it specific to any particular, maybe Amazon or Google Cloud, for which application this security issues has been considered, or is it from randomly as chosen like a generalized one?
So you answer. Yes, ma'am. Any more questions?
Yeah, the question is it generalized on cloud computing, generalized like Amazon AWS is providing Google Cloud, this service, and Google also providing, and many more vendors are into the market.
Sir,
This security, are you generalizing it, or is it for particular application?
no, sir, it is generalizing only, sir. It is not for particular model we have done. We have just started with, as our abstract only tells, we have started, not like, we have particularly taken some data sets from AWS or some cloud other, this one, and we have taken their data. And then for generalized model only, we have started, sir.
Then the next possible question may be like, to whom you are planning to deliver this product. The outcome of your work should be a product, right?
Correct, sir. Yeah, fair enough. That's what, sir. As ma'am told, we have to still yet implement LSTN model for that. Before doing that, now we know the ANN model that we have already implemented, and making the difference between the threat and the who's the normal user, that we are able to do with our student who are present in our with a group of 30-40 members. We have done. So now to implement it in the large scale, we want to make it a full package. That's why we 4 people are working on it, sir. So once this all comes, that is the next step of this paper, sir.
My suggestion for you,
Yes, sir.
first to try to understand AWS in
Yes,
detail.
sir.
Why means they are claiming that their security features are good enough.
Okay, sir.
And the Google and this digital ocean, when I'm going through their sites, or the article says they are having enough secured system for their data, whatever the users are taking from them, the services adopted from them.
Yes, sir. Yes, sir.
But yours is like they don't have security. Likewise, the presentation is beginning. The security issues are there. Likewise, you are saying, whereas the vendors are saying they are secure. So in this connection, first to make sure that for which cloud application platform this security you identified, so that this feature will meet their requirement. That is my suggestion.
Yes, sir. Got it, sir. You want to specifically tell me that which is having the flaws, you go through the flaws which is there, like in AWS and all. Later, I try to implement it.
Yes, ma'am. You are right.
Okay, sir. Thank you for that. This one, sir. Input. It's a very valuable input. Thank you, sir.
Okay, next presentation, the effectiveness of machine learning algorithm for real-time detection in cloud environment. Madasani sir.
Yeah, okay, one second. I present that.
Okay, sir.
Yes. So, definitely, the abstract cloud computing revolutions storage and processing, but introduce the new security challenges. Traditional ideas struggle with cloud stability and dynamics. Study explores machine learning and enable model more the real-time industrial direction. The evolved performance and benchmark data set using accuracy, precision, recall, and F1 score. The introduction cloud computing, scalable, flexible, and on-demand resources. Security challenges arise from the multi-key visualization and the dynamic scaling. Traditional IDs are limited by static rule and poor scalability. Machine learning based IDs can adapt and detect armed patterns dynamically. The study focused on enable machine learning algorithm, improved detection performance. The resource objectives evaluate the machine learning algorithm for cloud-based industrial detection. Compare NSL versus single model industrial detection performance. Assess accuracy, precision, recall F1 score, latency, and resource usages. Using real-time deployment facilities in cloud environment. The related work, the machine learning and deep learning increasingly used in industrial detection system research. Rare studies, random forest, cadence bursting, and deep networks achieve high accuracy. The NSM models inconsistently outperform single lane in complex cloud traffic detection. The key challenge dataset realism and scalability in cloud conditions. The methodology overview. Dataset which is ideal view performance. data cleaning, normalization, encoding, category variables. The future selection using information gain and correlation analysis models, baseline decision tree, logistic regression, SVM. Ensemble the random forest, random boosting, stacking, voting, classifier. The metric accuracy, precision, recall, and F1 score latency. The ensemble model framework, baseline detection tree, SVM, and random forest gaining, voting, stacking. The advantages: reduce bias and variation, better generalization, robust interaction classification. The goal capture variant intrusion behavior, data acceleration, and reader on Excel. The result and performance model accuracy decision, recall F1 score, decision tree, the 0.990 and 985.87. The NSM machine learning significantly outperformed single models, improved minority class detection and robustness, achieved real-time inference approximate 0.06 sample. The real-time deployment findings, cloud simulation with virtual machine showed low latency, CPU load less than 40%, memory less than 1 GB, scalable under traffic burst, suppose streaming data for real-time intrusion detection system. The key is future importance, flow duration, bytes, flow packet timing, TCP blocks. The challenge is data set limitations, lack for real cloud data. Future retain needs multi-tenant noise. Interpretability is usually need for explaining AI. The discussion on future scope. The ensemble machine learning enhances cloud intrusion detection, accuracy, adaptability, and speed. Integrity machine learning intrusion detection into semi-systems and the security automation. The online incremental learning, unsupervised anomalous detection, hybrid signature machine learning system, integration with the cloud alternate tools. The conclusion future work. Ensemble machine model of effectiveness real-time cloud intrusion detection achieve high detection rates, low latency, and scalability. Success depends on continuous real-time interoperability, system integration, and resource management. Ensemble machine learning promising but toward intelligent cloud security. Thank you.
Can you go for first slide, sir?
Thank you.
Any other questions, ma'am?
Sir, will you talk about your research question? What is the research question? Hello, sir. Madusami, sir. Are you online?
Yes, sir.
Madusami, sir.
Yes,
Yeah. Please say about your research question. What is your research question? Why you selected that as a research question?
sorry, sir.
What is a research question? And explain about why you are chosen that as a research topic.
Madhuswamy sir, how do you support streaming data in real-time IDS? For your proposed algorithm, you are saying it supports streaming data in real-time IDS. How do you use this real-time IDS using streaming data? Sir, are you there? Sir, are you there?
Madhuswamy sir. Okay, ma'am. Shall we go to next presentation? Next presentation name identification of abnormalities in health rate, long-term memory. Sushma ma'am. Sushma ma'am.
Yes, ma'am. I'm in, ma'am.
Okay, ma'am.
Okay, ma'am. Yeah, hi. The one more presentation is about good afternoon all. So the other presentation is about identification of abnormalities in the fetal heart rate using cardiography and that is your LSTM model, which we actually spoke about. So some next one. So again, we are 4 people are working on the same. So let's see the introduction. That is fetal heart rate monitoring. As we saw, why we actually came up with this was nowadays during the pregnancies, what we are seeing is, when the baby is born, that after the baby, after 6 months, 8 months, 10 months, it is we come across telling that the baby is already having a very low heart rate, and then either the hole is there in the heart, and lot of heart disease we are seeing in the babies, whether it is pre-born babies, and not only that, preterm labor is happening, and the baby is born with this one. So that's why we have worked with those data sets for detecting the fetal heart rate. That help. So what we are doing is we have put the LSTM model for this detecting the heart rate and drawing the using the LSTM model. So whatever we are getting CGT, what is the heart related, this one we are trying to get it. That is fetal heart rate monitoring helps us access fetal well-being, especially at high risk of pregnancies. Cardiography measures FHR and uterine contraction, but suffers from the subjective interpretation. Adolescents pregnancies have high risk such as plasma and preterm labor. That is what which I spoke about it. Then deep learning models like LSTM enhance CDT interpretation accuracy. So we are trying to implement our LSTM model in the CTG is what we are gonna see. So problem definition, what we have exactly done for that data, that is manual CTG interpretation introduces subjective leading to delayed diagnosis. High dependency on expert interpretation increases variability across clinics. Lack of automated real-time monitoring tool in low resources healthcare settings. Need for reliable AI-based solution to detect FHR abnormalities accuracy. What is the basic objective is to develop LSTM for deep learning model for automatic fetal heart rate classification, enhance diagnostics accuracy, and reduce subjective errors in CTG interpretation, provide a system capable of classifying fetal health as normal, suspect, and pathological, enable affordable and accessible parental care through automation. Proposed data method. So what we have done is we have taken 2,300 or 2,000 plus data CTG recordings of three trimesters, that is your 7th, 8th, 9th, which is of Kaggle data sets only, which is open source. Data processing, missing value correlation, outer layer detection. Model stack LSTM network using Adam optimizer and softmax activations. Evaluation matrix. What were the evaluation matrix under this was accuracy, precision, recall, again F1 score, specific, and AUC. So in that, what and all our experimental results was training conferences 4 echoes, batch size 42, learning rate point, then model achieve is again 98.37 accuracy we got, and 94.63 sensitivity, and then high F1 score, which is of 94%, and graphical results shown consistency learning with ARIA. We have shown everything in our paper, complete graphical results. Then what was the proposed deep learning models? Enhances fetal heart rate classification performance, reduces dependency on manual interpretation of CTG, improves clinical decision making, and ensuring improve timely intervention, supports personalized and accessible parental care for adolescents pregnancies. So that is what this paper was all about. Basically, when we are talking about preterm labor, most of the things what we do is we take CTG interpretation and we draw that, and we feel okay, everything is fine, and we go. But what we are doing is we are trying to input the LSTM model into that, and we have to put all those criteria which is related to the baby with 2,000 data sets which we have drawn from Kaggle, which is of which we try to put it in the data set, and we try to run it what and all under this differences in the with PB. This one came whether how is the heart rate, how is the heartbeat, what should be the size, what should be the height of the baby, and how it is whether it is breathing is normal or high. Basically the heart rate is high, low, or medium level. This is how it is done. So basically we have taken these three set with the Kaggle, and we have tried to implement that, and we have tried to do this one. Any questions on this?
How do you find out the fetal heart rate? What's the formula for it? How do you determine it?
Yes, sir. Yes, ma'am. Please, ma'am.
Hello?
Yes,
can you hear my voice?
Yeah, ma'am. I can hear you.
How do you find out that fetal heart rate using your algorithm? Any proposed algorithm, if you have? How do you find out that heart rate of this foot? Is there any formula for it, or you have to write anything?
The data sets, right, ma'am? We are taking, see, ma'am, first we want the scanning, which is there, that we are taking what was the height rate when the lady is going, we are taking the heart rates of the baby, whichever the CTG which is there. Based on that, it is being implemented, ma'am. On that, we are implementing the LSTM model.
What is the abbreviation for CTG?
Scanning, ma'am. It is a scanning.
Oh, you are saying this recording is in video data, isn't it? So based on the recording, how do you measure the heart rate? I am asking, how do you measure the heart rate of
That's what, ma'am. Cardiography is what we are talking about here. We see the scan data which is there, no, ma'am. On that, we derive through the Kaggle data sets. As I told you, I got direct Kaggle data sets of 2000. We implemented that data in this model and we have tested, ma'am. Like which is at the low, which babies at the high heart rate risk by whether it should be, like, for example, if I consider the baby heart rate should be under 80 to 90 in that range. If it is less than that, so we are trying to tell that it is not the baby is not okay in the womb, is what the fetal is not okay, is what we are telling, ma'am.
So the machine itself, it is calculated the heart rate.
Yes, ma'am. Yes, ma'am.
It's inbuilt one.
Yes, ma'am.
Your CTG recording has inbuilt heart rate machine, isn't it?
Yes, ma'am. Yes, ma'am. That is what we are trying to implement in the CTG machine only. The LSTM we are trying to put it, and we are trying to take the this one, ma'am.
Okay.
Yeah, ma'am.
Okay. Which model gives a better accuracy out of your proposed work with the existing? You have to compare it. Is there any comparison results that you have it?
Yes, ma'am. I'll take my paper. You want me to show my paper, ma'am? Is that what I exactly have done? I'll just share you that.
Comparison results with existing and.
I'll show you. Can you? Experimental result. I'm trying to show you that experimental result. Here, ma'am. You're able to view, ma'am?
No, it's not viewable. Can you share your screen properly?
Yeah, ma'am. Sure. Yeah, sure. Are you able to see this, ma'am?
Yes.
This is how it is done, ma'am. So we have deployed in that only, where directly it is showing the all data sets which is being done.
Okay.
Yeah.
Okay, ma'am. So you have to say LSTM is the best one for FHR abnormalities. We'll conclude like this.
For time being, ma'am, for time being. As of now, MS with the LSTM which we are seeing is the best, which is what I am seeing for the time being. But again, the improvement will be there, no, ma'am. Our, every time innovations is there. For this one is there. For time being, this is the best that we can give, ma'am.
Okay, thank you.
Thank you, ma'am.
Thank you, ma'am. Next presentation title is Enhancing Heart Disease Detection Accuracy Using Learning a Random Forest Approach. Karthikeyan sir. Karthikeyan sir.
Ma'am.
You can present the paper, sir. Karthikeyan sir.
Ma'am.
Ma'am, am I audible?
Yes, sir.
Ma'am, sorry for the inconvenience. My presentation was corrupted by something, so I present my paper in PDF format, ma'am.
Okay, sir.
Thank you, ma'am. Now, my title is my project paper title is heart disease prediction using machine learning algorithm. My guidance was assistant Professor K. Sundaradul sir. My name is Prakash Ambrose. And the abstraction is the heart disease is leading cause of death globally, about 17.9 million per year. The project was built a machine learning based on web application for early prediction, ma'am. The algorithm is used is random forest. The key parameters are age, gender, blood pressure, cholesterol, heart rate, etc. The technology was used to HTML, CSS, and JavaScript, SQLite, Flat, Chat.js. The result is shown either heart disease detector or not detector along with the confidence score. Our system analyzes users' health information and predicts whatever they are the risk of disease. The result is displayed in interactive, the show of pie chart. Ma'am. Let us move to introductions. According to WHO, 32% of global deaths are caused by heart disease. The early detection can save many people's life and improve treatments. Machine learning study past data and discover some hidden patterns. Algorithm compared include SVM and decision-making tree, random forest. Traditional diagnostics is time consumed and expensive, time consumed and expensive, but ML can quickly analyze large amount of data and provide predictions. The main aim is identify heart disease early and assist a doctor to make making decision. Let's move to related work. Earlier studies of ML models like SVM, random forest algorithm, and ANN. The random forest prefers a high accuracy and less low overfit. The data pre-processing like feather classing and normalization improves result. Flask and Web Django web frameworks are used for real-time prediction system. Many researchers have tried to discover different algorithms. Among them, random forest perform the best due to the reliability and ability to handle the complex data. That's why we selected it for our project. Proposed system combines random forest and SVM for high accuracy. It interacts with a wearable device like watches for real-time data collection. Displays the result using pie chart and bar graphs. Works on both web and mobile platforms. Implement strong security measures. It improves prediction accuracy and adds a visualization feathers for a better understanding. Users can modify their heart conditions anytime and anywhere with secure data storage and clear graphical results. In data flow diagram, user enters the health details and getting the pre-processing data, and ML model predicts the results. Predicted results stored in a database and the output is displayed to the user. Our system from data input the final prediction output. The result that goes through the pre-processing, the model makes the prediction, and the result is stored and visualization on the web app. Result tested using the patient heart database. Compared the algorithm, random forest, SVM. The random forest gives a high accuracy and a clear data collections. Graph shows the comparison of the model performance. The comparative proves that the random forest gives a more accurate prediction than others. It making the best choice for our system. Conclusion. Based on the ML web app, provides a yearly accurate detection of heart disease using Flash and SQL and Python for complete our web design functionality. Future scopes are we can build a mobile app using Flutterflow and React Native. Integrated IoT device for a living heart monitoring, and we can build a wearable watch for calculating the heartbeat prediction. It highlighted how machine learning can assist the healthcare system in detecting disease earlier. In future, the system can be improved with real-time monitoring, better models, and the mobile access to reach more users efficiently. Thank you, ma'am. Ma'am?
Okay, sir. Any questions, ma'am?
Which model gives the that is better prediction when you compare the existing methods?
The random forest algorithm, ma'am.
Okay, about you are asking this precision value or you are taking the accuracy value?
Both values, ma'am.
Okay. Did you find out any efficiency of this heart rate? That means heart disease prediction?
No, ma'am.
Then how do you say it is the best model? Random forest.
Comparison of the logical.
Based on precision and accuracy, you are saying this?
Yes,
this is the best model. But without efficiency, how do you predict this is the best model?
Ma'am, I can't understand the question.
So you're finding this accuracy, precision, recall, F1 score, isn't it?
Yes, ma'am.
So out of this only you have to conclude it. Random forest is best one.
Yes,
that means precision and accuracy. You take the values. The random forest is the best one. What about the
accuracy and precision, ma'am?
Okay, what about the efficiency? Did you find it the efficiency for your proposed work?
No, ma'am. We can find out in future, ma'am.
Okay. That's my question. Okay.
Yes, ma'am.
Okay, thank you all. That concludes session 1. On behalf of organizing committee, I sincerely thanks all presenters, our respected chairpersons for an enriching and insightful section. Thank you all. Thank you, participant. Thank you, presentation. Thank you, ma'am.
Shall we leave the meeting, madam? Any more?
No, ma'am. No, ma'am. No, ma'am. You can leave the meeting.
Yes, ma'am. Can't get it. Shall I leave the meeting?
Yes, ma'am.
Okay, thank you.
Thank you, ma'am.